The public narrative around brain-computer interfaces has been captured almost entirely by enhancement, the prospect of augmenting memory, accelerating cognition, or establishing neural connections with external devices. That narrative, driven largely by Elon Musk's public communications around Neuralink, has generated enormous cultural attention. It has also somewhat obscured what is arguably the more significant near-term story: the clinical therapeutic potential of BCI technology for people who are currently living with devastating neurological conditions and for whom existing medicine has essentially run out of answers. The therapeutic case starts with what we already know works. Deep brain stimulation, a form of targeted electrical modulation delivered via implanted electrodes, has been FDA approved for Parkinson's disease for over 2 decades. The control of tremors, rigidity, and motor dysfunction that it provides has been genuinely transformative for patients who had exhausted pharmacological options. More recent devices from Medtronic and Abbott incorporate closed-loop functionality. The system monitors neural activity in real time and adjusts stimulation accordingly, which represents a significant advance over earlier fixed-parameter approaches. Neuralink's first human implant, announced in early 2024, demonstrated bidirectional neural communication, the ability to both read neural signals and deliver electrical inputs with high temporal and spatial precision. In the specific context of paralysis, that capability enables the restoration of digital communication and motor control that represents an enormous quality-of-life advance for patients who currently have neither. The therapeutic extension to psychiatric disease is where the analysis becomes both more exciting and more philosophically fraught. Closed-loop devices designed to detect the neural signatures of depressive states and deliver corrective stimulation in real time are in early-stage clinical trials. The concept is appealing in a purely technical sense. Depression correlates with measurable patterns in prefrontal limbic network activity, and electrical modulation of those circuits has been shown to produce mood changes. But the translation from technical capability to appropriate clinical practice requires answering questions that neuroscience is not yet equipped to answer. If depression is a circuit state that can be switched off by an implanted device, who controls the parameters of that switch? What does it mean for a patient's sense of identity and agency when their emotional state is regulated by a device that their physician can adjust remotely? These are not hypothetical philosophical concerns. They are practical questions about autonomy and consent that will need to be resolved before psychiatric BCI applications can be deployed responsibly. The history of involuntary psychiatric treatment in the 20th century should make us particularly cautious about any technology that allows the emotional states of patients to be modulated without their continuous, informed participation. The near-term picture is one of genuine medical optimism for clearly defined neurological conditions, combined with a serious call for ethical deliberation before this technology expands into psychiatric applications. The paralysis and Parkinson's stories are compelling. The depression and addiction stories require the field to do much more work on mechanisms, on ethics, and on governance before enthusiasm translates into clinical deployment.